Right, we are live again. Wait for everybody to come back. There's nobody in here. Should be live again. I doubt it if anybody will come back.
Yep, I can see it.
Okay, somebody back. I'll hang about for everybody. We don't want anybody to miss anything. I mean, it was just getting to the... No, it wasn't. He was still trying to work through it. So, yeah, sorry about that. Somebody shut my PC down. My PC encountered an error. Should I do another... send another thing out on...
Are we back yet?
I'm back on Twitter, on YouTube, I think. I don't know whether...
Yep, you are.
Let me... I might have to send another one out again.
It's too quiet.
Think that was it anyway. Oh, no, wait a minute. That's not it. There you go. Right, that's it. There's a few people in. Let me send it back out again. Don't forget to share it out again for us if you can, please. Okay. People coming back in. I doubt it. I doubt most people would be like, I don't know whether I could be bothered going back and listening to that. But just know that of all of the, say, the proofs of actual...
I don't hear anything.
It's not on yet. What's the chance? Well, you can't hear anything even on YouTube? Or you don't hear anything now in Discord?
I can hear on Discord and on YouTube also.
Okay, thank you. Right, Robert.
I'm going to drop and rejoin.
Yeah, Discord's being a bit funny, so. I know. There was 24 people watching. Not anymore. 7 people I've got on there. Thanks so much.
I have nine.
9. Ooh, it's going up. I've got 8.
8,
Yeah.
yes.
Okay, I can't see why anybody want to come back, but this is the only place you will ever be able to hear the globe differential leveling. And anybody, if you ever try and engage anybody in conversation, they will probably do much worse than George is now, because George is the expert, I think. After Jesse Kozlowski did a Jesse Kozlowski, and the guy who probably doesn't live in Maine also did a Jesse Kozlowski, George was the next man, but now George has done a Jesse Kozlowski, and there's no one left. No one. So you'll never be able to hear anybody doing this again, I don't think. I don't think any of the more recent blue marble scientists can take this on.
Oh, I don't think so.
No, I don't think there's any. This is a dying breed, let's say, is the dogmatic globe surveying team.
Way too difficult of a challenge.
Not even the new guys, Darren and Kenny.
No way.
Too many contradictions.
However, since we're waiting for people to file back in, I, for one, wouldn't mind going through a similar conversation with that Realm dude and see how they do it on, what is he, concave Earth, or is that what he is?
Speaker, frequency,
Yeah,
magnets.
speaker
I
Earth,
don't
whatever.
know. Yeah, it seems.
Yeah, whatever they call
disjointed.
that Earth. I'd love to hear how they do differential leveling on that Earth. That'd
Yeah.
be phenomenal.
I don't know. I think it'd be tricky talking to anyone about it, really.
Could be. Could
Even
be fun though.
even real surveyors, right? Because you know what'll happen if a real surveyor has to talk about it. You know what they'll get called. So
I would
Yeah,
say
we don't
that
want to get into that.
concave will work with inversed refraction.
Yeah.
would it still work with the RBD face though? That's the thing.
Yeah, probably not, I'm guessing.
Okay. Well, it doesn't look like it. Looks like we've lost a few people. It happened last time as well. So I'll get the George is back on there. Now, this video is a 4-hour video and we are at 1:55. So I'm not too sure how long it's going to be. Just lost another one. Oh, he's putting that shit back on. I'm off. This is very important though, right? What I do is going to be much more important, relevant to this. And I'd say, although I don't know whether one of Blue Marble Science is one of the 7, he's going to need to look at this really in order to judge his reciprocal zenith angle. Bullshit. Because this is relative to that.
Roddy,
Short
Well, I
distance, though. This one.
I'll be honest with you, to have horizontals all switched and you've got to subtract your back sight from your foresight. I don't know. That just seems crazy.
no, you're subtracting foresights from backsights.
Okay. Well, that's wild. But what if you were to say you wanted to be super accurate and you went another 30 meters past your foresight with another measuring rod and you were making sure that you were dead on? Now you've got,
It's only on YouTube.
I don't know what you would do with,
Not on Discord.
like you're saying these horizontal.
What's that? Oh, right. Yeah, sorry. Let me get you guys. There you go. I knew there was something I wanted to. Who's that? Kevin? Sorting your cutlery out.
Intersect, but if you were to do double rodding, how would you work that out? You know, so like
Okay.
if you've got
Well, let's talk
one
about
rod,
double riding a second. Okay.
look, let me pause for a second. I just before I even said that, I should have waited and see if anybody else wanted to ask questions. I apologize. Make sure nobody else wanted to ask.
Yeah,
questions
before I
about
move
this.
on, is there's any questions on this? Does Mobius have a question?
I do, but
I
to be
guess
fair, I
Kevin
got to
has a
get going.
question.
Yeah, I got to get going pretty soon. So, but
Okay.
we already went over it a little bit, George. I've got plenty of questions, but I don't want to like frustrate you.
Well, ask them.
All that.
You're not frustrating me. Go ahead, ask.
All right. Well, for one of the questions I have is, how do you determine the instrument height when
You
it's
don't have to.
different? What?
It's arbitrary, however you want to set it. If you're doing the pole readings and reading the poles on the backside and foresight, you can set the instrument height at to whatever you want it to be, as long as you can read the pole, as long as you have enough pole to read.
Okay. So the instrument height has nothing to do with the measurements that you're taking in your foresight and backside?
No. Well, except for changing the readings. I mean, if I were, say, to take, say in the middle here, say if I were to take this now auto level and move it up, I'm going to have a different reading on the poles, right?
Yeah.
But the readings are going to change by the same amount as I root. If I raise the auto level up, say 40 inches, the reading here will be 40 inches higher, and the reading here will be 40 inches higher, because I'm guaranteed with the auto level set in the middle that as long as the distance between these two poles isn't much greater where I can read the poles, the changes are always going to be the same amount. If I raise the auto level up 20 inches, both readings are going to raise up, are going to read higher by 20 inches and so on. Or if I lower it by 10 inches, the readings will change by 10 inches. See, that's the whole thing in differential leveling is in one case I've got a backside, in the other case I have a foresight, and they both change the same amount. Since I'm subtracting foresights from backsights, that amount that's changed drops out. It subtracts itself out. If I added 20 inches on the backside and added 20 inches on the foresight, when I subtract that foresight from the backside, that 20 inches drops out, right?
Yeah, I get that. Also, one other question before I have to go. How are you plumbing these measuring rods to be perpendicular to the line of sight so that you get an accurate read?
Plumbing them to the, well, usually your rods, at least the ones I have a little bowl-size bubble on it, so you can set them vertical.
I know, but like in this diagram, how would, because for one, if you're doing one setup, say at 1A, you can make sure that the rods are perpendicular to the line of sight, but then it wouldn't be the same measurement at 2A because it would be in a different
position.
Well,
the thing is, the earth curvature is ever so slight over, say, shooting 60 meters or whatever between the auto level and the pole. At 60 meters,
so you can't tell that difference then?
Well, you're doing differential leveling. You're shooting the backside and foresight. So like I said before, initially, the amount of drop due to earth curve is the same in both cases. So you're subtracting, and so it drops out. It doesn't affect you. You can't tell whether you're on a flat earth or a curved earth doing differential leveling.
But you can tell if the poles are vertical or not. And if
well,
they're
how
parallel,
much do you think they're going to change? I mean, to get a 1
I don't
degree
think that they'll change
you
at
have
all.
to have the poles separated by 69 miles to get 1 degree. Do you think there's going to be much of a change in vertical between the poles over, say, 100 meters or 50 meters? It's going to be well beyond anything that you can adjust for.
Would you say that that it'd be impossible to get that measurement?
You could with a very accurate theodolite, but I mean, the amount that it's going to change your reading is so insignificant and so negligible as that it won't. Hang on a second, I got to get Con some food here. He's throwing this bowl at me. Hang on. Come here.
Hey, George with his dog. See now, George has just stated that the verticals wouldn't be noticeable. But as you can see, he's drawn all of his levels with a big slope on them. But apparently these verticals at either end, you wouldn't know that they weren't perpendicular, even though you would be attempting to make them perpendicular. But apparently everybody already knows that they can't be. It's not possible for them to be. Not both of them, anyway. You can't have them both being perpendicular to one line. That's not allowed.
Good boy.
Tricky question.
Good boy. Come on.
It's a good break. Good time.
Just not getting how you work out the
The
equation.
RBD face equation.
There you go.
You're not
Good
up
boy.
to date
R-
with it.
RBD minus
Face.
AC.
RBD face.
Go ahead.
RBD face. Yeah.
Okay, I'm
It
back.
never changes. It's always the same.
All right. Yeah, I was just wondering about the vertical in your rod, because it could be perpendicular at one instrument, but it wouldn't be perpendicular at the next instrument, and then it's constantly changing on this
But the
diagram.
thing, but over the distances in which you're doing this, even at 100, 200 meters, 300 meters, the difference in angle on that on those poles from vertical is
Well, yeah, like you said,
so
69
negligible.
miles, right? It would
you
be
only pick
69
up 1
miles for
degree
just
in
1 degree.
69 miles.
So
You only pick up.
how much would you be able to measure that over, say, 50 meters or even
Well-
1,500 feet? You know,
Yes,
how
you
how,
can do
how
it.
would you?
You could do it with a theodolite. You can't do that
Thank you
with
very
your
much
setup
again,
with using a
gods.
bubble level. You could never ever get the sensitivity in a spirit level or a bubble level or anything to know what the difference is. You'd have to have a very precision piece of equipment like my Topcon GTS 3B, which can measure an arc second difference. You can
Those are-
pick
those
up maybe. Pardon?
Sorry, those have computer boards on them, right?
Yeah. Uh-huh.
Yeah.
But that's only for doing the display and for looking at the tachometer wheel to tell you what the angular differences are.
It doesn't use a computer board to calculate the difference, the angles.
No.
Oh, do you know how that works? Like how it gives?
Yeah,
how
there's
it-
a tachometer wheel inside the instrument, a very fine tachometer wheel that's read optically and you process what the computer is used for is to process the readings off the tachometer into a digital display for you, that you read off your display on the instrument.
Is that where that curvature switch thing is that I've been hearing about?
No, this curvature switch thing isn't something that's like on the outside of an instrument that you're going to toggle on and off. It's something.
No, I figured it was
Just like-
internal, right? It's
Yeah,
like
it's
built into the
internal.
programming or whatever.
But that's not for measuring angles. The curvature switch, this curvature correction or the refraction. There's two corrections that are made inside of the theodolite if you want to invoke them. That's one for refraction. You have a winter and summer setting, and one for curvature. But that only affects your EDM.
Curvature switch confirmation from George once again. Within the instrument, curvature switch. Switch it on and off. It's like turning an auto level round and doing a backside and a foresight. You just switch it on and off. You can get rid of curvature by just turning an auto level round. But with a theodolite, you've got a special switch.
capability, electric distance electronic distance measurement. It has nothing to do with the measuring of angles, of the horizontal and vertical angles and the theodolite. That does not, neither of those corrections affect your angular measurements.
All right. Well, like I said, I got to get going. I wish I could have
Yeah.
carried this on longer. I wish I would have started earlier because then I would have been able to stay longer. But I know you had some stuff to do. So anyway,
Catch you later.
I guess, yeah, I'll talk to you all later.
So anyway, I don't know if that was worthwhile or not.
How would that change with the double rod, George?
Oh, the double rod, yeah. Am I done with this part that I have shown up?
Well, can you not just add another rod in? Or do you have to... See, this might be the bit that people might want to know about. This is the shared straight line segment double rodding. This is how you nutsack someone. Do a whole new... Have you got...
Well, no, I got to show you a top-down diagram how you would do it.
Top down? You know, just add another rod in there, because that's all you're doing, isn't it? Doing two rods.
No,
Yeah, that's what double rodding
you
is.
have a misconception
I think
about
you
what
might
it
have a
is.
misconception, but go on. Give us your
Okay,
idea.
hang on. I'll show you with double rod. Just a minute. Okay, and the double rod setup is we're looking at a top-down view right now. We're going to start at this point, and we're going to end up at this point. And what we want to do is establish level. Okay, so this is a top view. Here is a side view like we had. Here we have our starting rod. Okay, now in a double rodding procedure, the way I understand it, is we're starting here at our reference point, and we set up our auto level, let's say here, and we're going to shoot another rod with our auto level, right?
I don't know what Josh is doing
And
here. I don't think he does that, though.
so
Turn it down a bit. It seems
here
to
we're
be
doing a
banging
backside
louder
and a
louder.
foresight to these two rods, okay? Now, what double rodding procedure allows you to do is so that you can catch errors right away. Like if you're doing a lot of setups and you want to transfer the level position or the elevation position from here to here, say a mile away, a couple miles away, you're going to have a lot of setups. And if you happen to make an error along the way and you're not aware of it, you're going to transfer it all the way along. And then you catch it at the end and you go, oh shit, now I got to start all over again. Okay. What double rodding allows you to do is minimize.
I have to disagree, Ute. You guys don't understand just yet the beauty of the double nutsack drop that George gave us. That's entirely George's. Nobody else would have done that. Jesse Kozlowski attempted it with one, but George gave us the double. He's put it into the minds of everybody. This has to be done. There's no way around this. The double nutsack reversing into the reciprocal hump. It's the only way you can do it. You will become this is fascinating, and it will never be replicated by anybody else, and nobody else can replicate this. I will. I'll show you how it's done in reality. I mean, this isn't reality stuff. This is it's an impossible task. Realizing the Dornagon, it's what it's called. Differential Leveling, the Globe Perspective by George Knutsack. God rest his soul. Realizing the Dornagon. This is the entire reason why we've got the Dornagon.
The possibility of making an error. So what you would do with a double rod is, let's say, here's where we started, here's our rod. Okay. Oops. Okay. This is this rod, this is this rod. Now in double rodding, or let's just say let's just first do a differential leveling.
This is as hard as it gets.
Let's just say we have a number of steps here.
An impossible task.
And then we're going to set our auto level up in the middle.
Ladies and gentlemen, I give you, there is another video that we've got. Double rodding with George. But this is an impossible task for the dogmatic globe believer. Can't be done. George is going to give it his best one. I challenge anyone do better than this. Blue Marble Science, if you're listening. Go on, sorry.
Hey, sorry, Bev. I just want to say the simple fact of the matter is horizontal is a straight line.
Mm-hmm.
And that's what the tool produces.
Yep.
All right, thank you. I'm sorry. I got breaks to do.
Well, yeah, the unfortunate problem that comes with horizontal is that all horizontals are parallel. Which case, that's what makes this impossible, the horizontal paradox. George is going to try his best. I'm hoping Blue Marble, maybe Darren, perhaps Kenny. I don't know where they've gone. We'll see who's left. We'll have to be someone.
We got our auto level. We're setting it up at different heights or whatever. And we're, and we're shooting our level lines. You know, we've got all kinds of setups. We're shooting our level lines. We're doing our differential leveling. Okay. Now, so this is our top view. Here's our poles. Sitting here. Okay. So this is our top view. We're looking at top down to our pole. So here's our circuit, what they call our path or our circuit. In double rodding, you set up a second circuit. That is, you can set up a pole here, another pole here, say a pole here, and a pole here, or whatever. And what you do is you run two circuits at the same time. So you're doing differential leveling along this circuit here to get to the end. And we also start at the same reference point and we run a second circuit. We run a second circuit. They don't always have to be in line. They can be, but they don't have to be. So we run two circuits. This is what they mean by double rodding, is that there's going to be less chance if you make an error on this path or this circuit that you're going to make the same error on this circuit. So
see what George has done here is quite conveniently not gone with what double rodding is. It's a shared straight line segment in between two rods. It's quite convenient though. He doesn't need to access it. It's ECV. I'm not too sure he's aware of it either. You'll find a lot of people doing this just to avoid the actual thing.
As you go along, you can compare the elevations that you're getting by running two different circuits because you're making two different sightings on two different sets of poles. So the numbers you're reading are different. So the chances are of making an error are reduced. Plus, when you're all done, if both are run correctly, you can get a little more accuracy at the end by taking the two elevation readings and average it, because you've taken two different runs, two different circuits, and if they both run perfectly, they'll give you the same numbers, but the chances are that the numbers are going to be right on. You know, that the chances of that isn't as likely, but they should be pretty damn close. And if they're real close, you average them and you can get a better number because you've run two different circuits. That's all double run is. Double run isn't like you've been saying, Bev, where you set poles in front or in back and then sighting them at the same time. What you're doing is you're sighting two different circuits. You're going around two different circuits on a double run. Or, I mean,
A double run. See, George is completely mistaken. Everything is. It's terrible, but he has to. And nobody else will ever attempt it. It's impossible.
in a double rodding. If you look it up, you'll see that double rodding, all that means is you run two different circuits or two different paths from start to finish so that you can compare and find errors if you happen to make them along the way.
Yeah,
It's just to ensure more accuracy.
Two foresights and two backsights.
That's correct. Yeah. In fact, you can even do it with two different instruments, you know, when they do two different runs.
No, you don't even need two different rods.
No, you don't. You could. The very simple way of doing it is using the same set of rods and then just read different elevations. Say, do this circuit a foot lower than the other circuit. Start at a higher reference point, so that the important thing is that you're reading different numbers on the rods so that you're not as likely to make the same error. So it's self-correcting. Okay, well, whatever. If you look it up, that's what you'll find what double rodding is.
Yeah, two foresights, two backsights, shared straight line segment. That's your check.
No.
Every time you reset your level up.
Alrighty, if you want to believe it. It's okay. Anything else?
Well, I don't know. Mobius is gone now, so I don't know if anybody else got.
Yeah.
Anybody else got anything? And we can go over this some other time.
Mm-hmm.
So that was a pretty good presentation, George. Do you think you could get it better? Would you like to hear it when we put it out? Go over it again, or you say you're not going to be doing that at Geo's?
No, I'm not going to be doing it at Geo's. No.
That was that an exclusive for us then?
I guess so. I don't see doing it anymore.
Do you reckon any other globe surveyors will have a go at doing that, or are you the only one left?
I don't know.
Are you
You'll
the
have to ask
last
someone.
globe surveyor? You're not even a surveyor.
I wouldn't call me a globe surveyor. I'm not. I've never advertised myself as being a surveyor.
No,
I know the procedures. I know the methods, but I don't do it as a profession.
The globe surveying thing, aren't you? I mean, where are the actual? Well, there isn't any, is there? There's no real globe surveyors. That's why.
Surveyor is a surveyor.
Yeah, just a surveyor, isn't it? It's just a surveyor. There's no such thing as a globe surveyor. Because people don't, actual surveyors don't survey models, do they?
No, I wouldn't put an adjective in front of surveyors. You know, surveying is a profession.
Yeah, just surveyors. That's
and they have certain procedures.
They're all the same, aren't they? They all use the same tools and do the same job. There's no difference in any surveyors.
Well, there is in terms of speciality, how they specialize. I mean, you have certain people that are specialize in
quantity surveyors are definitely different than land surveyors, aren't they?
I mean, you got your land surveyors and you got geodetic surveyors. I mean,
there's no difference in those two. They're the same thing. I was meaning things like quantity surveyors.
What surveyor?
Quantity surveyors.
Quantity.
Mm-hmm. Yep.
Never heard of that.
Have you not?
No.
Is that because you've not been in the building trade?
Well, could be. I don't know. I've never heard that.
No.
I mean, I've heard of construction surveyors and, you know,
Yeah, they're just
plane
all the same.
surveyors
Though.
and geodetic surveyors.
Yeah, we decided they were all the same, aren't we? They were the same. With the quantity
Well,
surveyors.
the principles are all the same.
Not
The
for
principles
quantity
are the
surveying.
same.
It's
It's
not
just
the
that
same as surveying. Land surveying type thing.
No, I don't know. Like I say, I'm not familiar with quantity surveying or what you mean by that.
I had to do
Cool.
a bit of it. It's boring.
Could I ask
Sorry.
one more question?
Yeah.
If there's a difference between plane surveying and what you've got as differential leveling that plane surveyors would use for differential leveling, why would they ever need geodetic surveying?
Well, geodetic surveyors are doing surveying over much longer distances. You know, they're the ones that kind of like go cross country to set up boundaries and monuments and stuff like that. They're not just involved with, you know, grading and setting, you know, trying to level out a tract of land or something. They're more interested in finding elevations over long distances, places to put markers around monuments around for specific latitude, longitude, and elevations.
Well, would the same principle, the RBD phase, still apply?
Yeah, the
Always, it never
principles
changes.
are all
RBD
the
phase
same.
never changes.
Yeah, it would be the same, so it wouldn't
But-
matter. I mean, it would be the
but
same thing.
But geodetic surveyors are more interested in establishing fixed monuments
There's no
that,
difference. You just
say,
said.
your plane surveyors or boundary surveyors can go off of, you know,
There's no
for
difference. You said
marking
though, George.
property lines.
You can't say there's no difference in the surveyors and then say there's a difference in the surveyors. What's the difference now?
No, I said, Bev, I didn't say that. What I said is geodetic surveyors are more interested in establishing monuments that other surveyors can go off of. I mean, a plane surveyor or a surveyor in a construction company isn't going to be going cross country trying to establish points of exact latitude and longitude and elevation. That's the job of the geodetic surveyors.
Oh no. I use differential. Like, that's the question I wanted to ask you as well. When you were saying earlier, it's got to be in the middle. Like you had, I noticed you didn't
You
have
don't
any.
have to be. No.
Didn't
no.
have any
Bev,
horizontal
I did not.
distances, did you?
Oh, God. Bev, I didn't say you have to be in the center. The center gives you a balanced reading where the curve of the earth drops out. If you weren't in the center, then you have to start taking into account earth curvature, and the amount of earth curvature you take into account would depend upon how far off the middle you are.
Well,
but the earth curve
let's
drops
say you
out of the measurement if you're in the center.
Let's say you went 27 miles doing that method.
Mm-hmm.
How much curvature would you get? Doing that method that you say the RBD phase.
You don't pick up any. You don't pick up any curvature in differential leveling. If you go 27 miles, if you
So
start
there is no
at an elevation,
then,
say
or
of
you
5
don't
feet,
get any.
Oh, God. No, it doesn't pick it up. There is curvature, but it doesn't pick it up because of the differential leveling procedure.
So what sort of elevation do you get?
Say
then?
Well, won't you let me finish? I'm saying if you start, say, at a monument and
like zero,
some monument marker, and you want to establish a level at, say, 5 feet above that, and you want to transfer 27 miles out doing differential leveling, by the time you're done, you will have a level mark that is at the same height or the same level as what you started with. It will just follow the curve of the earth.
There you go. From George. It doesn't pick up any curvature, but it would end up level. So there's no curvature then, right? That's what you'd assume, wouldn't you? If you do differential leveling and differential leveling doesn't pick up curvature, and you can go 27 miles keeping the level with the same elevation, say for a canal or something like that, 27 miles long, same elevation, using this method, no curvature. But you said there is no curve. No curve.
You can't determine. No, I didn't say that. I said the curve drops out. I didn't say that there is no
The
curve.
curve drops out. That's
The
an
differential leveling guarantees that you will follow the curve.
It's an interesting term, that, isn't it? The curve drops out. It's not a normal surveying term at all. Maybe a globe surveying term. I don't know. There is no more globe surveyors, though. George was the last. There'll be no more. I'm still on a search to see if I can find them.
Of the earth.
We'll see.
If you were to say,
RBD face.
set your, just here, let me bring the diagram up again.
Okay, go on. That one with all three of them.
Yeah. Okay.
That one. That's the one.
You
RBD
see
face.
this now? Okay. All right. Now, let's say I were to take.
Is that
And,
for the Canadians? Is that one? 1A,
Canadians.
2A, and 3A. You know, it's just
No.
1, 2, and 3.
No,
Or 8. No.
I just one for the auto level, 2 auto level, 3 auto level.
Yeah.
Okay.
I like it for the Canadians.
Now, let's say I took the time that after I did my first setup here, my first leveling,
Yep.
and I want to transfer the height at R over back here by F.
But,
Now, one way I could do it.
That's horizontal, right?
Oh, God. Will you
Yeah.
please just let me finish this real quick?
Okay, I'm just checking though. Right? It is horizontal, isn't it? That line.
Which line?
The
This one?
from your auto level. The auto
Yes,
level
this is a horizontal
establishes
line.
horizontal.
This is a horizontal line that the auto level is establishing at 1A.
Mm-hmm.
This, if you looked at it, if I set a line parallel, take a line at the auto level, and I moved it down to the earth, it is tangent now
What?
to this level line that's following the curve of the earth, and will have the same amount of gap at this end as on this
Sorry,
end.
did you
We'll
say
have the
it's
same drop.
tangent? A horizontal is tangent to something.
Yeah, right here.
To the
You see
left
that
line.
little?
Hey, I do have one question. Just before you do that,
Yeah.
before you lower that red line,
Uh-huh.
if like the way you've got it set up right now, if you were to move that measuring rod that's at B, if you
Mhm.
moved it over, doesn't that throw your measurements off?
Well, yeah.
Just
When
so
you,
is RB,
what do you mean
RBD
move it
face
over?
still
You mean
work?
left or right? You mean left or right?
So if you moved the the measuring rod
Rod.
over out, like say you moved it over, 10 meters, it would
Yeah.
throw your measurements off, right?
Yes, it would. Uh-huh.
Yeah. So
Because
so
you
with
want to
the-
move your auto level, you want to, if you move the rod, you want to now move your auto level to be midway between. So you're going to have to move your auto level over too. 5 meters.
I see
If you
what's
move
up
the,
with the double rodding. How do you can't do double rodding the traditional way, can you? That's why you've got a problem with it. I see.
no, you can do
Yeah,
double
I
rod.
see. Does it not work on the
Was that
one?
Buster that was just speaking?
See, if Darren, if you are listening, there's your problem. It's not equal, is it? If you do like one at say 33 meters and then another one at like 66 meters, then they're not equal. You've got a problem. I see.
Buster,
Yeah,
was
that
that Buster? No, before that. That's asking me about the rod.
Well, yeah, the rod, if you had it at B and you moved it over, say, 10 feet out of the divot, I mean, that throws your measurements all off.
That's it, do too. That's it, double rodding. Well done.
Well, if you moved it there, if you moved it, say, there, then what you'll want to do is move your auto level. So, pardon?
No, just extend the red line. Don't move the auto level. Extend the red line from 1A.
Yeah, well, what you could do is this.
There you go.
That's it. Equipotential angle of adjustment. There
Yeah.
you go. Boom. Nearly got a double rodding going on here now.
Okay. Now, if you did that, now you're not guaranteed that the earth curvature is going to be balanced out. You'd have to move your auto level in between, say over to this position, if you wanted to not have to take earth curvature into account. If you're offset from the center or from the midpoint, now you're going to have a little more earth curvature on this end than you would have on this end.
And now, I hope you're listening, Darren. You can see the bit of problem he's got there. He's got a little bit more earth curvature in here than he has here. It's dropped out there, but here it's showing. So the double rodding is the one that shows you how accurate you are. This is a problem. It's not surprising nobody else has ever took this up. I'm surprising nobody ever noticed it either. Maybe it's just better to not talk about it. Keep it quiet. Don't let anyone know about it.
So you'd have to figure that in, and you get around that by moving your auto level midway in between. Then you don't have to worry about that.
Whoa.
Okay.
No.
Yeah, be careful there.
George, you see that there? You've got two rods in the middle. Now, can you see that they're not? You've made a triangle within your red lines there, even in your drawing. Like, would you not say that shows that your auto level's knackered? Or
What, my auto level, what?
is knackered?
Knackered? What do you
Yeah,
mean?
because that's double rodding. You've got in the middle where you've got your double.
No,
rod.
that's not double.
Yeah, it is.
Well, you want to call it double rodding, but that's not what really
But that,
double
that
rodding
would
is all
check for
about.
your error, and your error would be shown by that triangle being formed there, because they should be parallel in all reality. But you've got a triangle
No.
there. Now, I would say that triangle would show that your auto level's knackered, or you've made a drastic mistake somewhere.
Oh, no, not really.
Uh-oh.
Uh,
No? Is the yawn the new? Is it
the
advanced?
Okay, this brings up a good point. What I've always been trying to tell you about.
Would you? Oh, it's gone.
Is
Would
just like,
you not say that would be like a knackered auto level? Is that not like? Because that's in essence that's sort of like the double your two peg test, isn't it?
oops. God. Here, hang on.
Have you got a new keyboard, George, or are you just slamming the door?
I'm slamming the hell out of it. No, the problem is my microphone is built in, so it picks up the keystrokes.
Keystrokes. I wouldn't get a lot of strokes.
It's very sensitive to it because the microphone is right under the keypad.
Sounds like
Now,
it.
if I were to,
Sounds
What?
like it.
yeah, can't help it. I don't have an
Well,
external
just
mic
a minute
that I
before
can
you
use.
carry on, right, George? In that double rodding thing that we've just shown there, I say
Mm-hmm.
it's a check to make sure that your level's going right. In case you can't close your loop or whatever, then you are effectively doing a 2-peg test in between every transition that you're ever going to make. So you're checking your back sights with the foresights and double rods, right? So if you get a discrepancy, I'd say that means your auto level's knackered, but seems like you're saying that would be curvature of the Earth. So, like, why don't you devise a method to do that? It's really weird that you can't see that there's a problem there for either reality or there's a proof of your model in there somewhere. Can you not see that, George?
I'm going to show you a very easy way to use your odd level to find out if you're right or wrong. Okay, in the top here we have your flat Earth. Okay. Now I'm going to set my odd level up here.
You got some flat Earth.
The top diagram here that I'm working on, do you see it?
Straight line.
Yeah, the straight line here, and now I've set my odd level up.
Yep.
Okay. And now I'm going to shoot out with the odd level to this green rod here. Okay.
Yep.
Now, so now I'm going to shoot out. Okay, so now I've shot. And I've got a mark on this pole here. Now, I'm going to set up another pole right at the odd level here.
About 0.7 of a meter away, my one. Looking like yours, I think.
Can put it right up next to the odd level and get your mark here of where the center of the optics of the odd level is set up, okay? And we show it, and we get a mark on this pole or get our reading. Now, you can either take the same odd level or get another odd level and set it up here. So its optics are centered from where the first odd level shot. And we're going to shoot back, okay, towards odd level here on the left side. Now, if you're on a horizontal plane, you should hit the center of the optics of the odd level doing that by shooting back, by having it set at the same height. Now, if you shoot and you hit the same mark, say you're 100 meters away, and you shoot back, and you see the same mark, then you conclude you're on a flat Earth. But if you're on a curved Earth, this is what will happen. You set your odd level up. Let me redo this.
Wow. Looks like, is this Sean Slope? I think we've got Sean Slope coming on here.
So, is anyone allowed to come in?
Yeah, George is just playing his keyboard.
I'm going to set my odd level up here on the curved Earth. Okay. Let's just for the sake of argument at this point, assume that the Earth is curved. The top one I assumed it was flat. Okay. Now, I'm going to take this odd level and I'm going to shoot this pole at, say, 100 meters away, just like I did on the top diagram. So this odd level is going to shoot a tangent or a horizontal that's tangent to the Earth at this point. So this line is going to be parallel to the Earth at this point. So now I make a... Well, you think it's shooting up, but it's actually shooting a horizontal with respect to this point.
Well, if you go further back and extend that, would it not get closer to that black line?
To what?
If you extended it in the opposite direction, like if you turned your auto level round, would it not be pointing down towards that black line? Because it's pointing
No.
up at one side. Does that not make it point down on the other side?
No. Because if you
That's what
look,
I was thinking. That's what I thought horizontal was. Sort of even.
no, on a curved Earth, if I have a auto level set up,
Mm-hmm.
say at this point, and I have it shoot.
You drawing another picture for? What's going on? How many pictures do you want to go from one to the other?
Well, apparently you're not getting this. So
Just draw another picture.
now here's this line.
That's the idea.
So the thing is
Oh,
to
George.
you it looks like it's shooting up to a position here, but it's also shooting up to a position here from your terminology. Is because the Earth curves away from you in all directions from where you are set up.
It doesn't.
The Earth
does
falls
it?
away in all
Can you
directions.
just ask him if that's 100 meters or not, please?
Yeah, that's 100 meter shot, right?
Yeah, I'm greatly exaggerating, of course, of what's going on. All I'm saying is take your auto level, set it up, shoot a pole 100 meters away.
100 meters
Get what
is
the
a
mark
lot,
is
though,
up.
George, right?
Oh, God.
It is
All
a
right.
lot, though, isn't it? Come on.
100 meters?
Yeah. Do you
Yeah, it's
often
about
do
a
it?
little over 300 feet. That's the length of a football field.
Which is a lot, isn't it, for an auto level?
No.
Of course it is.
Hey,
No, it isn't.
wait a minute. Just thought of something, George. Like the thing you did with differential leveling was in just a linear fashion, just because for the diagram.
Mhm.
What if we were to do it in 3D? What if we were to do a differential in a triangle?
Trying.
Oh, yeah.
I'm not sure what you mean.
Okay, so let's say let me find the picture. Sorry.
If you
Blah,
do,
blah,
you
blah.
do one line, and then you could cross it with another line.
Wait. Oh God, dang it! Let me find the dang picture. So you had 1A, 2A, and 3A, but let's say you did 1A, turned, and did 2A, and 3A met back to 1A.
Close your loop.
Yeah.
Well, hang on. Let me just finish this, okay? We're
Okay,
jumping
sorry.
all over the place. I just want to say, all you have to do, Bev, is take your auto level, set it up, shoot a pole, say 100 meters away.
It's a long
Set your auto
way,
level
though,
up. So,
George.
oh, God.
Yeah, I
Hey,
know, but you're gonna have to say you say 100, but when I hear someone say 100, I think that's quite a long way, really. Like, what's
Well,
your
how far away do you want to be? How far away do you want to be?
About 50 meters is normally the best, isn't it? It's ideal for an auto level. Unless you want to go for precision, then you bring it down to like 20, 25, 30 max.
Okay, if you want to go 50 meters, hang on, let me think about what this is going to do for you.
Same procedure.
Are you going to be able to tell the difference significantly on 0.2 of a millimeter?
Why would I want to do that, George?
Because that's the only way you can determine whether or not you're on a curved Earth or not. At 50
George,
meters, you're going to have to be able to be
I
able.
don't give a shit about a curved Earth because I know the Earth is what is getting measured when I'm doing it. What do you mean?
That's what I'm
when you
trying to
say
do. I'm trying to
curved
tell you
Earth?
whether or not how you can determine whether or not you are measuring curve of the Earth or not.
Measuring elevation changes, George. It's an auto level.
Yes.
Right.
And your elevation changes will be in error. Your elevation changes will be in error if you're on a curved Earth, even at 50 meters, if you can read a difference of 0.2 of a millimeter. Well, I'm done here, Beth. This isn't going to work. You're interrupting again. Okay.
Yeah, well, you are using an
guys
auto
later.
level, George. Are you off? So that was a nice one. Has he gone? That'd be nice if he has gone. No. Are you
No,
Nah,
he's still there.
He's
sticking
still there.
around, George? I mean, I know you've finished drawing and all of that, but you know, we go and we'll do an after party of what the fuck George just did. It's been good. I really like it. You should do it.
RBD face.
What?
I always said RBD face.
RBD face. Yeah. Taught us a lot. Never changes. So the when you do the double rodding, you are basically using the shared straight line segment, and that's exactly what me and Spot On did. But because you have a water level, you can do the segments 100 meters. You're not governed by the optics of an auto level. You just use the water level and extend the segments. That's the beauty of it, George. It's all about that shared straight line segment and the differential leveling. It's dead easy. You can't do it with optics, but you can
Take away the
definitely do
optics,
it.
yeah.
Yeah. You can definitely
Not
do it with
completely,
the
because you
water
do have
level.
to look at the actual water
Right,
levels,
yeah.
you know. Just
But I understand why you can't get what double rodding is, Judge. I understand. Your model dictates that you cannot know what it is.
yeah, because that's really it, isn't it?
Yeah.
Nice to know what George does think about that. The shared strain, whether or not it's actually possible in geometry. Firstly,
Well, he was going through his numbers with the differential leveling, and then I apologize that I didn't even really think about doing the polygon with the 1A, 2A, and 3A. Just didn't think about it before because he was going through his numbers and doing his thing. But if you were to do 1A, 2A, 3A in a polygon, you know, like a triangle, does that formula still work out to close your loop?
Well, it sounds like if you do 1A, 2A, 3A, 4A, 5A, 6A, 7A, blah, 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 to infinity, you're just making a Dornagon.
Yeah, but what about if you just do a few
can't
A's?
be an elevation change, can there? Because you got to go back up. Once you go down, you got to come back up to close the loop.
I'll show you.
If you always have to subtract your foresight from your former backside, that's crazy. Crazy. I don't know.
I know you're still here, George, listening. Look, I'm going to see that there. Is that what you sort of mean? Like if you were to do your version of double rodding and go all the way around, would you end up with a Dornagon? I think you would. I think that you've just sort of demonstrated with your version of the thing, because you can see the different lines there are just offset a bit.
But that's just 2D. What if when you start getting into
that's-
3D?
That is 3D. That's the 3D concept of the Dornagon. It's the only shape that you need. If you want to imagine you live on a ball, the Dornagon is the only shape that you will ever need. Because you're just dealing with straight lines, shared straight line segments.
Yeah, but I don't know. I'd have to see it in the polygon fashion.
Well, that's a nice one that you found, isn't it? Nicely done, George.
What does he have there?
It's just got double rodding. It's just got a route that it's took.
You don't want to talk about it there, George?
Indian.
No, I'm just trying to find Bev some references for double rodding. Give me a
I know
chance
what
here.
double rodding is, George. It's a shared straight line segment. I know even
No,
when
it is
you
not.
geometrical
It's taking two different
principles.
circuits at the same time. No, it's running two different circuits
Well,
to
do
check
you
yourself.
agree that if you were to use a shared straight line segment, as in the double rodded, it would be even more accurate than that? Would, wouldn't it?
This
Yeah,
isn't
like
about what someone else has done.
Yeah.
This is about what you can do.
For the using the geometric principles like you are doing when you use surveying, then the shared straight line segment of a double rodded run, of a true double rodded run, would definitely give you the accuracy and the check to make sure that it is a shared straight line segment all the way along. Do you not think, George? I mean, I know it gets tricky, doesn't it? Because then you'd have to face the facts that if somebody designed a water level test with a shared straight line segment, you might have to contemplate what it might mean if certain results were got through. As in a shared straight line segment. It's scary, I bet.
I still can't get past the fact that if you were, let's say you were on a fairly like salt flats or whatever, and if you were doing the differential leveling and every time you set up your back sight was higher than your foresight, I would almost think of any surveyor, if every back sight was higher than your foresight from the previous setup, you'd be like, man, something's off.
Yeah. Yeah, you'd find that within your first two peg test before you start.
Yeah.
Right, George? You can see that, the problems. You'd definitely work that out, wouldn't you? There's something not right here. Because I know you did you tried to tell us about a two peg test, but it didn't sound like you actually knew what a two peg test was, George. You do know what a two peg test is, don't you? That you perform every time before you set your auto level up for working.
Have you ever done a two peg test?
Yeah.
Do you do it every time?
Absolutely.
Bullshit.
Do you not? Do you not do a two peg test every time, George?
I don't use an auto level anymore.
Oh.
I used to.
I thought you said you've still got one.
Yeah, I still have it, but I told you guys that I've abandoned it in favor of precision theodolite. It's much easier to collimate and check
Is that
and
your
ensure.
GTS?
Say what?
Is that your GTS?
Yeah, the GTS 3B.
Is that a theodolite?
Yes.
Is it not a total station?
Yes.
Is that a theodolite? I
A
thought they were
total
different.
station. A total station. A total station is a theodolite that has EDM capability.
It's just a total station, though, isn't it? Like the direct
Oh,
name for
God.
it would be it's a total station and not a theodolite.
It's a theodolite with EDM capability.
It's a total station.
Oh, God. Okay, it's a total station.
Okay, right. So you've given
A
up
total
the auto
station.
level
A
for-
total station
for a total
has,
station.
as a subset, theodolite capabilities.
Okay. Does it have
It's a
auto level?
theodolite with a laser.
Does it have auto level capabilities?
Yes.
Oh, because you were like you're giving it up. Do you not have to perform a two peg test every time you use a theodolite total station?
No, there's a different way to ensure the collimation of the horizontal and vertical with the.
The collimation.
Yeah.
We're not talking about collimation, are we?
Yes, we are.
Not with an auto.
You don't? Do you know what collimation means?
Yeah.
What does it mean? What does it mean?
Not with an auto level, though, George. Right?
With the total station, with the theodolite, what does collimation mean?
It's like, what does it mean, George?
I'm asking you.
Yeah, I know. I heard you. What does it mean, George?
I know what it means. I don't think you do, though.
Okay. Well,
Tell me.
Let's pretend nobody here
knows. No, let's pretend.
There's just you here, George.
Let's pretend you know. So describe it to me.
Let's pretend.
Let's
pretend.
Sorry.
You're the man, George, that's teaching us.
No, you're just trying to weasel out of this because you don't know what it is.
I don't. Like George, you're the one teaching us. Please tell us all what collimation is. See what's happened here, right? George has gone from not knowing how to do a 2-peg test with auto levels into him saying about a theodolite, now changing the theodolite to a total station, and now wanting to do collimation test, but wanting me to tell him about the collimation test rather than him telling us that he knows what the 2-peg test is for an auto level. A very usual procedure where you'll find when asking people that don't know what they're talking about questions. Very clever. They've been practicing this for quite a while. With respect to an auto level.
I'm waiting, Bev.
What are you waiting for?
We're waiting for you to tell me what collimation is.
I've just said, George, nobody here has got a clue what collimation is. Please tell us what collimation is with respect
Buster
to
knows.
the auto level.
I think Buster knows. He made a comment earlier that I helped him understand what collimation was.
Okay. Please tell us what collimation is with respect to the auto
I just stepped
level.
in. Go ahead, George. What is collimation? Nothing?
Phase 1, phase 2. Come on, guys.
Yeah, I know. We watched the video. But that's what I want to know with George. What, with respect to the auto level, George? No?
What? I'm tired, Bev.
It sounds like it.
Oh, man.
I'm tired of playing these games with you. When you don't know an answer, you try to put it on somebody else. This is the game you play.
I'm here.
Did everybody hear that? I think this is where George. No?
What?
Is that? Who's that? Somebody out.
I was just saying, that's me. He's trying to whizzle out. That's all. Sorry.
Yeah. No problem. Listen to this.
I'm tired, Bev.
It sounds like it.
Oh, man.
Tired, Bev.
I'm tired of playing these games with you. When you don't know an answer, you try to...
Blue, of course we knew what collimation was. George was getting out of understanding, telling us what a 2-peg test was. The same as you, Blue. You've said that you've never done a 2-peg test. George has just said he doubted the fact that we do a 2-peg test every time. Well, yes, you do. You have to know that your tool is in calibration. You do a 2-peg test when you get it out of the box. George doesn't seem to know that. I don't think anybody actually knows how you do a 2-peg test. And I notice you've been waiting for a long time there, Blue, to say that. But that's George being dishonest. And you guys, because you can't do a 2-peg test. According to you, two-peg test would show the curvature of the Earth. That's only because you don't know what a two-peg test is. So well done, Blue. Yeah, and of course we do know what collimation is.
To put it on somebody else.
You
This
Okay.
is the game you
George.
play.
I'm here. Can you hear me, George?
Yeah, I hear you.
What is
do you want?
collimation? I'm a
Say what?
truck driver. So what is collimation?
Blue, I'm pretty sure I've got you on record. I'll find it somewhere, and when I find it, I'll clip it and bring it back to you. I'll just get this as a Blue Marble Science. I have done a two-peg test many times. I'll find that clip, Blue, where you do it, and when I do find it, I'll let you know. If anybody knows where it is, to hear any one of the old videos where I'm talking to Blue Marble Science about him never doing a two-peg test. Blue Marble two-peg test. You've called us a liar too many times, Blue. You have said that you haven't done a two-peg test. George has just told us then. He said it's bullshit. When, yeah, you should do it every time. Everybody should know that. Ridiculous, Blue.
Do you know?
No, I'm asking you. I'm a truck driver. I don't survey. What is collimation?
Ask Bev. He seems to be the
No,
man.
I'm asking you.
Oh, gosh.
I don't know what it is either, George, so please, can you enlighten us?
I've never heard it before in my life. I would like to know from George because he seems to know more about all this than me.
I went through
All of
this
us.
in this server once before. I discussed it in
Nobody's here.
detail.
Yeah, there's obviously people here that don't know, George. Please.
I wasn't here when you went through it before.
Well, I've never heard that word before, and having to do with the auto level or Seattle level.
I've been here all
Because
night
you
through this
guys don't
conversation.
use
I
the
still don't know
equipment.
what collimation means. So please, George, can you enlighten us all?
Well, why don't you go back to Bev's old show where I discussed it?
No.
Why don't you tell us now, George? You're here. You're here now. We're listening. Come on. Can you
Well,
tell
what do
us
you
what
want to know about
collimation
it?
is with regards to an auto level, please?
Simple explanation is that you're just aligning the crosshairs that are tied into the prism in the compensator to be aligned with horizontal or level at the point that you have it set up. That's it. You adjust it. You adjust the compensator adjustment screw to bring the crosshairs in alignment with true level at the with the plumb or the pendulum that's inside the auto level. You need the crosshairs to properly indicate your horizontal as established by the prism or the pendulum.
Okay.
Okay, George.
So,
George,
wait.
what's the compensator, please? Because I don't know what a compensator is.
Yeah, Bev put up a little diagram there showing you the compensator is the pendulum prism.
You might want to take
in
that,
there.
George, then you can show people next time when you're talking about it.
No, I'm just saying that the pendulum prism floats freely inside the auto level housing. And then you have your
Where's the screw?
objective lens in the front, and you have your eyepiece at the back that you look through, and then there's a little lens that's in between the pendulum prism and the eyepiece that your crosshairs are etched into. And you need that to be aligned with the light path that comes from the prism. All this stuff is mechanical, so they can get out of alignment. And so you need your horizontal crosshair to be centered with light beam that comes from your prism, pendulum prism that comes from the compensator. And there's a little adjustment screw right by the eyepiece that if you unscrew the housing, you have access to that screw, and you can move that screw clockwise or counterclockwise to get the crosshairs to line up with the light path that's coming from the prism, the pendulum prism in the compensator.
So it's not a screw on the compensator then? Because you can't really.
No, you don't have access. You do not have access to the compensator. That's deep inside the outer level housing.
You did just call it a compensator screw a bit earlier.
Yes, it's not attached to the compensator.
No,
oh, Jesus Christ.
Yeah. It's like calling it the lens frigate when it's not that anyway.
So the pendulum prism, is that free moving then?
Yes. That's right, isn't it, George? I don't
what?
So how does the compensator affect the pendulum prism then?
It doesn't. The pendulum prism is part of the compensator.
Mm-hmm.
That floats freely inside the outer level.
The auto, isn't it? That's the auto in the auto level.
Yeah.
Yeah.
The prisms in the compensator are attached to the pendulum. As the pendulum moves, as it rotates the prism. So the light path changes. It gets tilted at an angle as the pendulum moves back and forth. And once it's dampened out and you have your auto level balanced or leveled properly, the pendulum basically is like, you can think of it as being a plumb that's hanging vertically. And the prisms are attached to that pendulum. And when the pendulum is at rest and rotating freely, you know that the pendulum prisms are aligned with horizontal or level at the housing of the outer level. So now what you have to do is make sure now that the crosshairs that are etched into the lenses that's between that compensator and between the eyepiece are aligned in the light path so that it properly indicates where your horizontal or your level line is. So there's a way by adjusting that little screw, you move the lenses around so that the light path intersects
excuse me.
Intersects the crosshairs properly.
Did anybody notice that he's using level and horizontal interchangeably the last few minutes?
Yeah, because he's talking about the level that's adjusting, making a horizontal. It's really easy to forget that they're meant to be different when you're talking about a level providing a horizontal. And he's what George is talking about now, the collimation of the auto level, is adjusting a screw. Don't ever adjust your screw in your auto level. Take it back to the shop and get it calibrated properly. But in order to know that it's not calibrated properly, what you need to do is a 2-peg test, not fuck about with the fucking screws in the back of it. And that's what George is getting away from, is knowing how the 2-peg test works. Because he knows he's got, as long as you have it equal on either side, then the curvature drops away. But that's not how you do a 2-peg test. The very way you check an auto level for it still being in calibration is to do the thing that George says adds curvature in. They're stuck. That's why these dogmatic globers really have a problem. And what George is showing you now is our ECV, existential cognitive veiling. I don't know whether he's doing it to shield other people or whether his mind is doing it to shield him. I don't know which way around it is. Don't know.
It's all mechanical.
It's just a reticule, George. It's not etched into the lens.
Yes, it is. It's etched into a lens. It's etched into a lens. It's etched into a lens that's between the...
Like if you look at that drawing, it's eyepiece, lens, reticule, fixed
the
prism,
reticule.
pendulum
The reticule.
prism,
The reticule.
prism.
See,
You notice the way George keeps talking over us and then he gets upset? Another common tactic.
Such
George
an idiot.
Yeah,
I can't believe it.
George, that's nice.
Yes, that is nice. I mean, you're very maddening. The reticule is a piece of glass. It's a lens in which the crosshairs are etched into.
It's just a straight piece of plastic or something with lines on it, George.
Huh. Well, it's a lens. It's a glass lens, not plastic.
Lens. It says it there. There's a big arrow on it. It says eyepiece.
Well,
lens.
enjoy your evening, Bell. I'm out of here. Okay. Goodbye.
Go and get your cocoa. See you later.
Yeah.
Nice.
Take care.
Lot, George.
He was acting like he was yawning when he was saying he was leaving.
Oh, Bev, why you gotta be so obtuse sometimes?
It's the way George likes it best. Right, so yeah, that prism it is just a glass piece. And, you know, the light hits that thing, comes straight through the light ray at the object lens, comes all the way through and just hits the prism. Gets bounced down to the pendulum, which is the auto bit, free floating with a couple of magnets to keep it stabilized. And then it goes through the other fixed prism, and then you look at the bit of glass at the end of the fixed prism, and you look through the hair at the image on the end of that fixed prism. It's pretty easy.
So the pendulum is inside the compensator. Well, I've never used one, so I don't know.
Yeah. Yeah.
So that's inside, free moving.
I'll do this, right, because this is it takes a bit for some people to get.
Damn, I thought George was gone. He's still here.
No, he's listening in. He's
okay.
He's
Listen to
listening
Bird.
for what he can get.
Little bird, the bird.
Oh, Redmond, why you gotta be so obtuse all the time?
Oh, you got me there, George. Damn.
Right, here we go. So this, I have to do this quite a few times, but I don't mind doing it. See, that's the eye looking through the end of a thing, and we'd have the camera on there. But the only bit that you actually see and what you look at and everything that you're doing is within that red box. Because as you can see, the horizontal light ray comes through the focusing lens, hits that fixed prism, hits the pendulum prism, hits then, and then you see that end of the fixed prism. That's what you're looking at when you're looking through that thing, and you're only looking through the eyepiece, and then you've got the hairs, and then you've got that bit of glass with the thing on it. So all of your triangles and all of that with whatever you're doing within the stadia hairs and the horizontal, it's all done within that like front 2 inches of the auto level.
Oh, I get it now. Yes. I wasn't looking at the diagram properly, but now yes, yeah, I get it.
The rest of
Is that the guy's eyebrow, or is that the top of his head?
Yeah.
Very bad haircut.
Yeah. It's just a line, all right.
But-
No need to get overboard on it.
It's a globe.
It's a line, and it's
It's just
accurate
auto level.
to the
Okay, I'm an admin of this server, and while George is here, we can't be fucking saying globe and shit like that.
But you always subtract your backside from your foresight.
Yeah.
RBD face.
Way.
RBD face.
Always.
Always. Never changes. Always the same.
Never changes.
It's the other way around. You subtract your foresight from the backside.
Oh,
RBD
George,
face.
why do you gotta be
Still
so
here.
equilateral all the time?
What if you do
So
it in what if you do it in a triangle? What if you go 1A, 2A, and then 3A meets back at 1A?
Huh? What?
Ballers Canal, the 1A, 2A, 3A. Internal. You could have them each as a mile, equilateral. That shit. Could even have your angles, couldn't you? It would be 60, 60, 60, wouldn't it?
Yeah.
Damn. Who's moving their house out?
It's George. He's got his keyboard.
Oh, he's got a keyboard.
Yeah.
Okay. He said he was gone.
Internal mic on his keyboard. Sounds cool.
No, it sounds bad. I gotta keep it 100.
I like to think that what he'd done is he hadn't got a keyboard, but he's got a load of wire and he hooks up cupboards and drawers to different buttons on his keyboard, so he can just slam doors and open drawers.
Oh, like a soundboard.
Mm-hmm.
Huh. Didn't think of that one.
His delete button was the kitchen cupboard.
yeah. He's probably got string and little pulley wheels.
Yeah. Pedals. He's ingenious like that. Is there any chance that the dear departed moment silence Jesse and Jeff are going to come back, George? Or have they ditched those characters? Will he come back with new ones?
What do you mean come back? You mean come to talk to you guys?
Well, no. Just to help the Globers out a bit, because they seem to be a bit stuck with this level horizontal and curvature thing. You're struggling, we know. You're not going to get any help.
None of us are struggling. You seem to be the one that's struggling here, Bill.
Sean G got rid of the hump the other week. I mean,
yep.
Walter Bislin modelled it as a hump. You know, Lake Pontchartrain, but Sean said there's no chance it's a hump. How can it
No,
possibly
there isn't
be
any
a
hump. Everything's level.
See, we're getting there. There's no hump, right?
He just said it.
Yeah.
So if there's no hump and it's always drop, do your 1A, 2A, 3A in a triangle.
The thing is you're confusing what drop is. Drop is when we use the term drop, we mean from a tangent line that's drawn from one position.
No, we
No.
mean drop. Like, it's quite obvious what drop is.
You know, drop in this sense, and describing Earth curvature, is not like drop on a hill.
Please describe what you mean by Earth curvature, George. Do you mean elevation changes?
No.
Right, so what do you mean by Earth curvature if you do not mean elevation changes? Please explain.
Okay. Think of it this way. Take a soccer ball. Okay. Now, from the point in the center of the soccer ball to every point on the surface is the same distance, right? From the center.
This is earth curvature you're talking about.
It's a lot of stitching
Well,
involved.
you agree with that?
Football.
On a soccer ball or a sphere, if you go from the center to any point on the surface, that distance is the same. That's what we call the radius of the sphere or the radius of the ball.
Yeah, I know what a radius is. Yep.
Wait.
A lot of stitching on a soccer ball.
Oh,
No,
Jesus
okay. You know what a
Christ.
sphere is. Don't confuse him.
No.
Sorry.
He's talking about earth curve on a soccer ball. So, I mean, like, let him go. I mean, we all know what a soccer ball is.
See, that's the part. You guys get so caught up in all these word games and minutia.
Just
I said I'm sorry.
Jesus. There's stitches on the soccer ball. My fucking
Yeah, stupid. I mean,
Jesus
imagine
Christ.
thinking an earth curve couldn't be displayed on a soccer ball.
Fuck.
Equidistant from a center. Go on.
Yeah, we all know what a radius is, George.
All right. So every point on the sphere is at the same elevation. Elevation is basically measured.
No.
Yes, it is.
No, the radius is always the same.
Elevation is the distance from the center.
No, no, that's the radius.
And that's elevation. That's how
There's no
elevation is
elevation of the
measured on a
ball.
sphere.
Nobody says that. What's the
Yes,
elevation
they do.
of the football?
Everybody says that. Anybody that knows anything
Soccer
about
ball.
spheres.
What's the
talks about-
elevation of that soccer ball?
The radius would go up to a mountain then, if that was the case.
So what?
The radius.
See, I don't know why somebody took a radius of a mountain. It's stupid. But just know, next time you go to a sports shop, ask them, what's the elevation of that soccer ball? They'll know what you mean. George knows what you mean. Anybody will know what you mean. Elevation of a soccer ball.
Radius isn't the same as elevation, or else the radius would go up into the mountain.
The elevation on the surface, yes. You can go and extend your radial line to get elevation. That's what I was going to get to next.
Different radiuses. That's what he's talking about. If you've never heard of it, the differing radiuses of a soccer ball is equivalent to earth curve or elevation. I don't know. Let's see.
But Bev kept interrupting. The thing is elevation is measured from
interrupted then.
elevation is measured from the center of the sphere.
If that
the
was
center
true,
of the sphere to the surface is what we call a radius. That is, the radius is points on a sphere that are all at the same elevation. Now, if you want to measure to points above the surface, like on a mountain or the top of a person's head or whatever, you extend that radial line to get what the elevation is. Elevation is measured with respect to the center. Oh, Jesus fucking Christ, Bev. Can't you ever shut up for once?
Well, I just noticed
My
that little
God.
slip that you did where you were talking about a football and then you said a mountain. I don't know, it's because Sugar Cookie gave you that out before, but you were talking about a football and a radius of a football, and then you slipped in a mountain.
I did not slip in anything. I was just answering the question put to me is, what is elevation on a mountain?
No, elevation
Don't you
of
listen,
mountains
Bev?
is measured
Aren't you listening to
by
your
differential
question?
leveling, right?
Aren't you listening, Bev? Ask.
I was listening.
Yeah. So when you say with a radius, you start in the center, right?
Yes.
All right. Who started in the center to get the outside of the rest of the radius?
Huh? What?
I said, who started in the center to get the rest of the outside of the radius?
Outside.
I know it's a dumb question.
How did you measure
Yeah.
it? I think is what he means. How did you measure that
The
radius?
center. Yeah.
What do you mean? How do you measure the center?
How
The center
did
is a
you
definition.
measure the radius, George? How do you measure the radius of a football, for starters?
Take the circumference and divide by 2 pi.
Wow.
what about Mount Everest? Is it the tallest mountain because it's measured from mean sea level?
I would expect so. I don't know for sure, but that would be a good guess.
Yeah, but I'm trying to go back to the start of knowing the radius. Who measured from the center to the surface? You know.
Radius is a definition, just like circumference. If you can't measure the radius directly, you measure it indirectly. Most measurements we make are indirect measurements, never direct measurements. You can't measure.
There you go. There's an admittance. When he's talking, George there's talking about, obviously, he's talking about on the globe. Because obviously, all measurements are direct measurements. Otherwise, what we do is we call the other ones calculations. If it's a measurement, it's a measurement. Indirect measurements are normally called calculations to normal people. Difference between
You cannot measure. You cannot measure. You cannot.
measurement.
Oh, Jesus fucking Christ! Yes.
George, will you stop blaspheming, please?
Oh, you quit interrupting.
I just asked about the center portion. That's all I was asking. Who went to the center and then measure it from there?
He can't measure R. Everyone knows that no one can measure R. That's right.
You can't,
George. You can't.
You can't measure it directly. You can measure it indirectly. There's any number of methods that you can get what the radius is indirectly.
You mean you can calculate something?
No, you don't calculate. You measure it indirectly. You take the circumference, and the circumference is directly related to the radius by a constant. The constant is 2 pi. You double the radius, you double the circumference. You half the radius, you half the circumference. They're directly related. They go 1 and 1.
Yeah.
No, wait. So if it hadn't been measured, so you can't assume anything across.
No, there's no assumption. Jesus.
Okay, so who's been to the center?
It's an indirect measurement, just like most measurements we make are indirect.
He means calculation. When he says that, he means calculation.
Okay, cool. Calculated from what?
Well, he keeps going circumference, but he's never measured that either. So, I mean, he's just making that up.
Geodetic surveyors
he makes up to the next.
I haven't made it up. I haven't done it personally, but geodetic surveyors have.
Measured the circumference?
Yes.
How did they do that?
It's been done several times.
How did they do that, George?
By going over the surface of the earth.
You got a man that I can check up on and see how he did it?
Yeah, just look up geodetic surveying. Look up the great, I forgot what it was called, the great
No,
Indian
he should have a great
survey.
man.
Huh?
Great name. A great name.
What do you mean,
Not
a great
George.
name?
Great name, George Washington, Christopher Columbus.
Are you sober?
No, there's nobody that's measured the circumference.
That's what I wanted.
Right, George?
No, the circumference has been measured several times.
How, George?
The British have done it.
How, George?
By doing geodetic surveys over the surface of the earth.
How?
I just told you.
No, you didn't. How
Geodetic
did they do
surveyors.
You can't measure it, George. It cannot be done. It's never
Yes, it
been
can.
done. It's not.
Really?
Yeah,
Really?
really.
Huh. Interesting.
You have a really bad understanding of what a measurement is and a really bad understanding of knowing what can be done and what cannot be done.
Yeah. Very good, Bev. Okay.
How do you get geodetic measurement of Earth if none of the land masses, like all of the land masses, aren't connected?
I just had me a couple questions. That's all. I'm gonna sit down. Enjoy the rest of my night.
Are you just gonna Keep quiet to the questions that you can't answer, George.
Booyah! Booyah! I like it.
It's Saints are beating the Patriots.
Yeah. Hold on, now.
Buccaneers, sorry.
Oh yeah, okay, cool.
I'm interested in the question that's still on the table for George. This
Come on.
geodetic surveying that's apparently been done to measure the circumference when none of the land masses are connected. How did they do it, George?
He doesn't know. It's like the radius thing. They all claim it and then get really stuck when we say it can't be done. It's impossible. It's always claimed, never actually been done, George. There's not even any method you could tell us how they did it. Because I think you know real deep down that they haven't done it.
I'm sure if he did know, he would tell us.
Well, he's keeping it quiet, obviously. I reckon it's code 33. I reckon that.
And holding secrets.
It's the new code for. It's not going out live though, George. So I don't think anybody can hear. Nobody to signal you out. You call to. Nice of you being here and hanging out with us though. You should do it more, George. Maybe then we can go over some of the stuff that we've got. Did you hear Sean G and that one? Because we're going through it now. Video. The one with you're in as well. You come in at late. Part 3.
3, 2, 1.
He said some stupid shit as well, George, you know.
There's no hump.
I bet if we go over this one tonight as well, there'll be a bit more. Remember that time when you said that people that aren't surveyors and aren't practice surveyors have got no chance of measuring the curvature? You're not a surveyor, are you, George?
Well, I'm bailing now, but George, thanks for coming over and educating me. Laters.
Yeah, see
you. Bye,
later.
Watercliff.
See ya.
See you later, Water.
Later on.
Mr. Sensible.
Our very own Mr. Sensible.
Depends on which perspective you have.
Yeah. You didn't know
So come on, George. There's a question on the table.
It's hard work with measurements, you know. Like can you remember when we first got together, DP, and we did that? You did that measurements or calculations.
Yeah.
That's fucking one of the earliest ones, and it's still bang on, isn't it? Right?
Oh, absolutely.
That's the logos, right?
Do you measure reality or calculate a fantasy?
Yeah. The competition, you can get to it.
Ooh, I found it.
I think George is busy calculating his fantasy.
There you go.
Yeah.
There you go. There's the original.
Sugar cookie, that's all wrong.
How dare you?
If they did that, then Mount Everest wouldn't be the tallest mountain. So
You just add 59 miles to everything.
yeah, that's that. If you did that, then Mount Everest wouldn't be the tallest mountain.
And the thing is, he's working out a constant radius based on a sphere. But I thought they lived on a geoid, which wouldn't have a constant radius.
Yeah, they think they.
Uh-oh.
Well, I don't even know whether they think they live on anything. Other than what NASA give them. I'm not too sure. I think we all think that we live in reality.
Purveyors do it all the time.
Yeah, and we all
That's all I
know
live
that
in.
we're too small to see anything, and you can't actually see any curvature anywhere ever. It's just some people imagine they can measure it, which is good. It's good that there are people like George imagining that they can measure it.
Subtracting the back sight from your foresight every time.
Yeah, we'll have to go over that. We'll have to get our little books out with a little backsight and foresight column.
I'm interested in doing that triangle, Bev, next time I come up to you.
The water level.
No, the surveying triangle, like Buster was saying.
Mm-hmm. You
Instead
do it with you could do it with the water level also.
Yeah.
Oh, you mean like peg it out?
Okay,
yeah, we could do that. Could see how good you are. I mean, what you have to remember is that we're on the beach. So
I was gonna say you got to do RBD face when you do the triangle.
Yeah. It does look a bit different, doesn't it?
I'm on the same mission as you, DP. Trying to get a drone to fly.
Herbed face. Get a beat going to that.
There you go, like that.
You gotta change the letters to RBD.
See if I get this plugged in. See if I get some lights.
I think George has fallen asleep.
Is that super fishies?
Pondering on his question. Yeah, super fishies.
And Emilo.
Oh, bitch. Get out of here.
Emma's not fond of the MLO, though.
But we don't care what Emma thinks.
Well, we do need a new mascot for Emma. She needs she's not happy with Emilo. I wanted to get an angry Emilo, but she doesn't want to give us a portrait shot of her snarling her face. Which I can't understand why, because a snarling face Emilo would be cool.
Yeah, it would. A little bit of a highbrow.
Yeah.
One side.
Let's see what this. No lights.
You still awake, George?
About RBD Malo.
Oh, DP. Why you gotta be so monkey some bitch all the time?
It is what it is.
Hey, Bev, have you ever read the manual on your auto level?
Hang on, George. There's a question on the table for you. Do you want to address that one first?
What's the question?
Really?
Yeah, I haven't been listening.
Buster, do you want to go again?
So what?
Yes. If you were to do 1A, 2A, 3A in a triangle, would the formula still work?
In a triangle? What do you mean?
Yeah. So if you did 1A and 2A, and then from 3A back to 1A.
Okay.
Sorry.
To do what? To level, you mean?
No, your differential leveling that you said it would work, but if you did it from 1A, turn 60 degrees, 2A, turn 60 degrees, 3A, turn 60 degrees back to 1A, would the
What about-
formula still work out?
Yeah. Yes. It's always going to work if you're leveling.
Just saying yes is not quite sufficient.
Well, that was a question. You asked me, would it work out? I said yes. What more do you expect?
I mean, could you show it working out?
Well, work through the numbers yourself. Go and do it. Do you have a auto level? Do you have a staff?
Google it.
Do you have a staff? Do you have an auto level in which you can play with?
You don't need a staff, do you? Or do we need a staff now? I'm glad that we do. I'm glad we've come round to that.
Well, if you're going to read the numbers off and do a backsight and foresight to read your poles.
You mean
sure.
like a measuring rod?
Yeah.
Yeah, I think they're
People call it different things. Measuring rod, staff, pole, rod, Philly pole.
Yeah.
All names for the same thing.
But it's
Range
necessary, right?
Well, if you're doing leveling.
Yeah. Which is what you do with an auto level, right? And there's
that's not the
many
only
other
thing you do.
uses of an auto level, is there?
Oh, yeah. With your auto level, you can measure distances.
Stadiometric range finding.
Yeah.
That's just an estimation, though, right?
That's why they call it range. It's not a distance measurement. It's a range finder. George, you know that.
Range, distance, same thing.
No, it's not.
Like
Yes, it is. Distance from the auto level.
Yeah.
Distance from the auto level to your range pole.
Range pole?
Yeah, that you're going to read off your,
The measuring
use your
rod.
stadium marks. You're
Yeah,
going
the
to use your
measuring rod.
stadium marks on the auto
vital,
level
isn't
to
it?
read your range pole.
Measuring rod, range pole, whatever.
Yeah, your measuring rod's vital for that, though, right? It's even more important for that.
Well, yeah, you have to know what the vertical height
So
is.
can you
between
think of
your
any
stadium
other
marks.
reasons to use an auto level that don't require the measuring rod being a vital part of the, I call it a trifle.
Auto level.
Maybe even 4 people, but... What do you reckon, George?
So what?
It's vital, right?
What is vital?
The measuring rod.
Measuring is what?
The
is
measuring
vital?
rod,
Oh,
George.
so he's-
The
he's
measuring
getting
rod,
late.
it's
Don't-
vital.
Yeah. What? Who?
I don't know. It seems like your audio's cutting in and out, Bev. I'm not getting
You are-
complete sentences.
You are clipping a bit, Bev.
Measuring rod. That's what he said.
Obviously, George can't. The conversation that we're having, because that is what we were talking about. So please, George, answer the question.
What's the question?
Would you not say that the measuring rod is a vital part of the equipment of an auto level?
Well, if you want to do leveling, proper leveling over uneven terrain, yeah.
And what else would you use an auto level for, George?
Like I said, you could use it for measuring distances. You can also use it
Which
for
you
measuring
also
horizontal angles
need-
to probably
horizontal-
within a few tenths of a degree.
The auto levels don't measure angles, do they, George?
Horizontally, you can. The base is calibrated in degrees.
Not calibrated, George.
Yes, it is.
It's
Look
got
at your auto level.
it's
The
got
base has.
dials on it, yes. Very crude.
Yes, it's crude, but you can measure angles. I didn't say that you're going to measure it to a high degree of accuracy, but you can get a pretty good estimate of certain horizontal angles. Of course, it's not going to be as good as a precision theodolite that can measure down to arc
Would
seconds,
you
but you can
use an
easily.
auto level for measuring horizontal angles, George?
depends upon what your application is.
For any application, if you required a horizontal angle to be measured, would you use an auto level for that, George?
Yeah, if I don't need a high degree of precision, I've used it for that. I've used it for measuring and closing triangles. You can do it pretty well using the auto level.
Measuring and closing triangles.
Oh, wait a minute. If you were to do your version of the differential leveling in a triangle, you would always measure up, no matter what. So instead of measuring down, you just always measure up.
Huh?
What is that? Even if you turn round, Buster?
Yeah, well, yeah. So like if you did it in a 1A, 2A, 3A in a triangle, you just always measure up to from your foresight to your backside. You just keep measuring up, measuring up, measuring up, measuring up.
Well, that's not always going to be the case. Depends on the terrain you're on. If you're on hilly terrain, sometimes you'll be measuring up, sometimes you'll be measuring down. Depends upon where the rod is.
That's what I
whether it's on a hill or in a depression.
I asked you earlier today if you would have to change the equation because we've got
You don't have to.
RVDFACE.
Again, you don't have to. As long as you subtract the foresights from the backsights, you don't have to change anything.
Well, you'd always be measuring up. You know, you're from
No,
your
you don't have to. No.
You know,
I just happened to show it on that diagram, but in some cases you can be your foresight, your backsight can be higher than your previous foresight, or it could be the other way around. It could be a mixture of them. It doesn't matter.
It's the difference between the levels, right? The differential leveling is just the difference in between the levels whenever you reset your level up.
Yeah.
You measure the difference between the last one.
Yeah,
and the new
that's basically what you're doing. Is you're just
you transpose
establish by reading the pole, by reading a backsight on your new setup and comparing it to the previous foresight. All you're doing is getting what the height difference is between the backsight and the foresight, and it doesn't matter if the previous foresight is lower than the new backsight, you'll get a positive number. If the Jesus, Cap, can't you shut your mouth just for 10 seconds?
You never stop monologuing,
Fucking Christ,
George.
you're annoying shit. My God.
You never stop. So you establish one horizontal, and at one end, you get a point on a staff, and you are then establishing a new horizontal and marking the difference between the two levels, the two horizontal levels. And you are just marking the difference between them. That's it. Differential leveling. Very simple, George. Two horizontals and a difference between them. Now, those horizontals are parallel. It's amazing. I know. Fantastic.
No, they're not parallel.
They have to be, George. You're violating.
No, they
the law
don't have to be.
You're violating the law of non-contradiction if they're not parallel.
Violate a law of non-contradiction. Oh my God.
Wow, that woke you up a bit, George, right? So do that for breakfast.
Yeah. I've tried to describe a test for you and Buster to do, but you've refused to listen. And you could determine very easily whether or not your horizontals are vertical, or parallel or not parallel. It's very easy to test.
Horizontals are never vertical, are they, George?
Oh, Jesus, Bill.
They aren't, though, are they, George? Horizontals never are vertical. That would be ridiculous, wouldn't it? Anybody that said that would be...
Why do you even say stupid things like this, Bill?
You were the one that said it.
I misspoke. I corrected myself.
I know, and I was just confirming with you that it was a misspeak, and that never happens, right? A horizontal could never be the same as a vertical, could it? Because they're always perpendicular to each other.
Very good, Bob. You must be reading Euclid.
No, just perpendicular. I understand the basics of geometry, right, George?
Very good, Bev. You get a star.
But you know that horizontal and vertical are perpendicular, aren't they? Always.
Oh my. Boy, you're a wizard. You are so quick at this stuff, Bev. It's amazing.
I know. It's fantastic, isn't it?
Yeah, it's awesome. I mean,
Why is it
it's
the only one getting
absolutely
patronising
awesome.
here is you, George?
Is it time to be condescending and ridicule now, George? I mean, you running out of steam here?
Yeah, I think he is.
It was Buster
Your
in the
computer
law of
malfunction.
non-contradiction that made him flipped it, I think.
We've been nothing but cordial and polite to you, George, and you just come in with the crap.
Called him an idiot earlier.
Well, either one of y'all.
It's pathetic, George. Man of your age. So anyway, George, can we go back to this geodetic survey that apparently happened to measure the circumference? Have you conjured up an answer yet? How did they do it when the land masses aren't connected? Was the question. Or did they just survey across the land and then guess the rest?
RBD face.
I'm really interested to find out how they did it, George.
RBD boat face.
Boat face.
Boat face. It's a boat face lie. Just wonder why I got laughed at when I said that if the horizontals aren't intersecting, it violates the law of non-contradiction.
Because George doesn't understand geometry, obviously.
Yeah.
There's got to be a law of what's that other one? What's the new one?
Stolen concept.
Stolen concept fallacy. Somewhere in there, somewhere. Can't use straight lines to say that straight lines are bent. Well, in fact, you can't use straight lines to say that straight lines don't exist. Rather. Well, certain straight lines, perpendiculars. Horizontal doesn't have a perpendicular, apparently, if you live on a model. That right, George? Horizontals only exist on your model along the vertical, at the point. That's what I've heard. Is that right, George? Or have you not looked that far into the geometric problems that you've got?
Feed that cat.
The next door dog.
It's usually when it thinks we're going live, it starts acting up, right? That's what it used to be.
This is a show cat.
Be hard for George in here with no backup, though.
So what's happening, guys? Did we get anywhere with the presentation? I missed most of it. Did George come in with a breakthrough, or?
I think exposed a lack of understanding would be a better way of phrasing it.
George not understand? Come on. Did you ever consider, DP, perhaps that it was you that didn't understand?
I've considered I think I
In
pretty much
Montreal, you don't.
understand geometry. George
I'm
is
just
back.
busting your cup.
George
Say
is
what?
Hey,
back.
George.
You got an answer yet, George?
So what?
The question that you've been asked about 4 times now.
Oh, I didn't hear any question. I was letting Con outside.
Can you stay around for it now, and then perhaps
Okay.
we might
What's your question?
get an answer from you.
What's your question?
You claim the circumference has been measured geodetically. How did they do that when none of the landmasses are connected? Did you hear it that time?
Yeah, you don't have to do it in a straight line around in a tall straight line.
So you're taking a wavy path to measure a straight line. Distance, I mean.
And what is your problem with that? The Earth has been pretty extensively surveyed geodetically.
How did they do that across the water, though, George? This is the question.
I didn't say they did it on the water, on the land.
The land, yeah, the land. So we know that the land has been surveyed because we know how that's done. Differential leveling, right? For measuring elevation changes.
Yeah, I don't know how it is over there in Europe, but you can find these geodetic markers all over the United States. In fact, just here in this community, I know where there's at least 5 of them, and I know there's more than that.
There's one every 200 meters down the side of the canal that Rumpus is doing, you know. Everyone heard that. Did you know?
No, I was not aware of that. Like I say, is I don't know how they, how you guys over in Europe, set up your markers or designate them. Here, they generally have brass markers embedded into concrete in the ground.
Yep, very much the same here, George. I don't know whether everybody realised that then. We've not really had many chances to talk about Rumpus and his test. But at Bedford, there's a bank in between the 2 canals. And every 200 metres, there is a benchmark. There's one of these things that George is talking about. One of these markers, geodetic markers, just benchmarks. In the concrete. And nobody bothered telling George about it. It's probably because Rumpus didn't even check. Didn't even know about it. Doesn't even know what they all are. Wonder where Rumpus has gone. Has he done a Jesse Kozlowski? I think he has. Do you reckon he's coming back? I doubt it.
But I just been reading about your auto level, and if you're trying to set up stabs no more than 50 meters apart, then it doesn't look very hopeful that you would be able to measure the curve of the Earth using your auto level.
We can measure elevation with the auto level, George, and we can show people how that works. Now, we know we cannot measure a curvature to level because we know level is horizontal and there is no curvature to that.
Well, actually, it is on the Earth. Level is curved, and that is the problem. When you're doing differential leveling, you cannot tell whether you're on a flat Earth or a curved Earth because you're maintaining constant elevation. Constant elevation on a flat plane is all can be connected with a straight line segment, whereas constant elevation on the Earth follows the curve of the Earth, and so it's basically would be if you connected all the points of equal elevation at various points, you'd get a curved surface that would be basically like the surface of the sphere.
Though, George, level is horizontal.
No, it isn't. You've been down. I'm not going to go down that road with you. I've heard that 100 different times from you, and there's just no point having that discussion, Bev, because that's your belief.
Yep.
I'm not going to try to change it.
You have a belief. I have a knowledge, George. You have a
No,
belief
you don't have any knowledge. You have
the
beliefs.
level is a circle, but it's not.
Yes, it is.
It's not. Level is
on a sphere. It is on a spherical mass. On a spherical mass, level is a circle that's parallel to the surface.
Parallel
That's
to the
fancy, George.
surface. Yep. How can it be parallel? Parallel straight lines, George.
Nope.
Circles are not.
And unfortunately, your auto level does not have the degree of resolution needed in order to do a test.
It's not
over
doing
50
a
meters.
test. It's an auto level, George. It establishes horizontal, so you can
Yes,
use
and
that
you can use those horizontals.
as a place of
Yeah.
reference to measure from.
That's correct,
That's it,
Bev.
George.
But as you move the auto level, your horizontals will change. But over 50 meters, they're not going to change enough for you to be able to detect it with your auto level. That's the problem.
So it's a straight line.
No,
That's
it's not
only-
straight. Well, as far as your auto level is
Your auto
concerned,
line
yeah, it
is a
appears as a
straight line,
straight
of course
line
it
because your
It
auto
is a
level
straight
doesn't
line.
have
That's
the
why
accuracy in
Why
order to
it appears as a
differentiate.
straight line, George, because it is a straight line.
No, it appears as a straight line because it's within the error of your auto level. Your auto level isn't a exact piece of equipment. It has a resolution limitation, and the curvature is within that resolution. So you can't see it. It gets swamped out by the
There's
errors
no
of your auto
curvature
level.
to a horizontal, George.
No, well, see, you really need to study your instrument more and what the specifications mean, because you're just fooling yourself into thinking that everything's horizontal, because you cannot register the curvature or how much changes there are due to the curvature because of the resolution of your auto level.
There's no curvature to a horizontal, George.
I didn't say there was.
Well, since an auto level establishes a horizontal plane of reference, then there's no curvature to that.
That's right, at each setup. But the instant you move your auto level to a new position, you establish a new horizontal, and those horizontals
Which
are
is
not
straight.
parallel.
They're all straight, right?
Yeah, they're straight, but they're not parallel. They would intersect because of the fact that the compensator readjusts itself every time you change the position of the auto level.
Horizontals intersect, George. Have you heard what you're saying?
Yeah, it's not the same horizontal.
Why are you saying that?
Because they're not the same horizontal. Your horizontals are only specific to
intersect, George.
your horizontals are local to the position in which you have your auto level set up. That's the issue.
Horizontals do not intersect, George.
Well, actually, they do.
Wow.
Horizontals established
geometry, just as I
at a
said.
given position do not intersect. They would be parallel. But the problem is you've moved your auto level, and when you move your auto level, you establish a new horizontal, which is not the same as the previous horizontal.
Who's told you that, George?
It's obvious.
See, that one question, that's the thing that we search for. Who's told him? And there is no answer there, because nobody has told him that. Nobody's ever told anybody anything about this sort of stuff. You make that shit up for yourself. So obvious. Left in aporia. It's obvious who's told you that. Who told you that, George? It's not obvious to me who's told you that. That's why I asked you.
Nobody's told me that. I can see that,
George.
Well, it might sound ridiculous, but it's a matter of fact.
So nobody's told George, but George has told a lot of people. George has handed out a paralogism. Nobody's told him that. George has decided that horizontals have to intersect. And George has told everybody else it has to be. There's no other way. Well, we are getting to the end of this, but this is what it's all about. George, God rest his soul, has told a lot of people these things. A lot of people. We've been watching it for 4 years. I sort of feel guilty for myself as well, because I've probably brought this around. I'm pretty sure if I hadn't have come round telling everybody that level's horizontal, giving them proofs for it, George wouldn't be in this position now. George wouldn't have had to make up that level isn't horizontal. For some reason. I don't know why. He has to have horizontals intersecting as well. It's a must. Terrible. You do realise our two-peg test is done, right? Horizontals do not intersect, do they?
Oh, Bev.
Oh, Bev.
I wonder why you sound so exasperated.
For you, George. It's in that.
According to your manual.
Yeah, this bit here, I think he's come to the end of it now. Like, you know. What can he do? It's pretty obvious to everyone, right? George is the only guy that's left doing this. Blue Marble's going to try it, but I mean, how can Blue Marble do anything? He's done reciprocal zenith angles. That's ridiculous. Stick to the actual surveying methods. We do have the other one, double rodding Thursday.
How do they recommend you do the two-peg test?
See, now, again, this is George doing the two-peg test. He doesn't know. Blue Marble doesn't know. None of the Globers will ever be able to tell you how they actually do a two-peg test for the auto level to make sure the auto level is within calibration. Because they've set themselves up for a fall already within their methods.
What should be the diffs? Yeah, what they have a test in there for doing your two-peg test, and they tell you how far to put your staffs apart. How far do they tell you to put the staffs apart?
Oh, I don't know, 50 meters.
No, 30.
60 meters.
30.
All right, 30 meters then.
All right, so your auto level's in the middle. It's in 15 meters away from each peg.
How far do you put yours apart when you're doing the two-peg test, George?
I change. Depends on
What does your manual say?
My manual is typically around 60 meters.
All right. So do you do 60 meters then?
I do various.
Right. So you don't always go with what the manual says then, right?
But I'm saying,
that's good to know.
You obviously don't even know what your own auto
you
level
forgot
is
before. Can you remember when you said you don't use your auto level and you don't actually know how to do a 2-peg test?
I did not say that.
If you just
Jesus,
looked
I
in the
said,
manual,
Bab, I did not say Bab, I did not say that. I said I no longer use the auto level. I used it for years before I got the
and that was
auto
when
light.
you said about us not doing the 2-peg test every time. Does it advise in the manual that you do your 2-peg test first thing every time when you get your auto level out?
No.
Does it not?
No.
Oh. When does it
as
say
long as you don't bang it around, as long as you're not rough, as long as you don't, as long as you don't rough handle your auto level, it will stay in calibration for a long time as long as you don't
When
rough
does
handle
it say that you should use the auto level and to perform the 2-peg test, George?
If you've had rough handling of it.
All right. Is that the only time you should do it?
It's when you might want to, for sure, check yourself. But I typically check myself about every 2 weeks.
But you don't use an auto level.
When I did, years ago when I used the auto level, I still use it, but not on a regular basis, not like the theodolite. I'll set both the theodolite and the auto level up periodically to check one another.
Right, so if you've not used it for a while, then would you not get it out and then perform a 2-peg test just to make sure it works properly?
Sure.
Right, would you not do that every time just to make sure it's working properly?
I don't have to do a 2-peg test each time because I can collimate my theodolite, sight the horizontal with it, and then put the auto level on to the tribec and see if it's shooting the same horizontal. I can check it against a theodolite.
Would you not just do a 2-peg test to make sure that your auto level's working properly?
Not every time because it's a real pain in the ass to do it.
I don't know, DP's here. How long, DP?
Sorry, I wasn't listening to George. I just zoned out.
I can check the auto level against the theodolite.
How long did you say, DP, it takes?
I can collimate a theodolite in 5 minutes and check the auto level against it.
Okay, just keep talking, George. Doesn't matter. It was all right. I was only asking DP. George seems to think that a 2-peg test is a lengthy process. How long would you say it takes?
My first one took about 10 minutes.
There you go.
15, maybe.
First one, George.
And I was within a millimetre, George. First 2-peg test.
Millimetre over what distance?
It was about 25 metres, I think. 30 metres, something like that.
Nah, it was further than that, the first one.
Now, was it further?
Yeah. But does it really
matter? Tell me, over what distance? Over what distance?
George, does it matter?
Yes, it does. Yes, it does. You said you were within 1 millimetre over what distance?
The distance we did the 2-peg test.
Yes.
Yes.
I'm asking you, what is the distance?
The distance that we did the 2-peg test over, George.
Yes. What is that distance?
That was the distance that we used.
Oh my God, Bab. How obtuse can you be? I'm asking you. Give me the number for that distance. How many meters?
George, we didn't do that. Because you don't, do you?
Yes. The shorter distance you use, the more inaccurate.
You know, when you did your drawings earlier and you had 1A, 2A and 3A. You didn't put a distance between
I
them
told you.
at
I
all.
told you at the beginning what the distance was.
Well, no, listen, I'm telling you now that you didn't put anything on that drawing, right? So we didn't put anything. We don't do that. You don't do a distance for the
Yes, you
two-peg
do.
test.
Yes, you
put
do.
Two
Yes, you
pegs
do.
in on the floor, don't you, George?
You have to know
You
the
put the
distance in order to know the accuracy.
pegs in
Bev,
the
over
floor,
what distance?
George.
Bev, over
This
what
is where
distance?
George shows. You put the two. This is where George shows he doesn't really know anything about a two-peg test. If anybody wants to know, you can come in and we do it live. Pegs in the floor and move the auto level from the middle to the side. Right? You've got it there. You've got it there, road in front of you, George. George,
DP told me 25 meters.
Road there.
Bev, DP just told me he was within 1 millimeter and 25 meters. That means he has an uncertainty of 8 arc seconds.
George, ask him. George, ask him how did he measure it, George? Ask him how did he measure it, George? George, ask DP how did he measure it?
Not very accurate. Not very accurate. 1 millimeter and 25 meters is a sloppy 8 arc seconds. That's horrible.
Sloppy 8.
That's horrible.
Sloppy 8, DP. Sloppy 8.
Ask me how it got measured, George.
You're the one that just told me. You were within 1 millimeter and 25 meters. That means that you're worse than 8 arc seconds in the accuracy of your auto level. That's horrible.
Yeah, you should have been more accurate than 1 mil, DP. You should have gone to like a point something of a mil. You know, like we do, George. Right? Is that how accurate he should have been? What point what of a what? How accurate would you have been, George? When you do your two-peg test?
Over 25 meters, I would have been well within 1/10 of a millimeter if I could have done that at that.
Yeah, with an auto level.
How would you measure that on the rod?
You don't use a measuring rod to do that. You use your own targets. The best way to get a very thin line to sight, you need to get a target where you have a line.
This is George explaining how a two-peg test works. There'll be a lot of people from the dogmatic globe side that do this because they haven't got a clue what they're doing.
My targets, the graduations on my target are on the order of 1/100th of an inch that I use for doing the
1/100th of an inch.
Yes, 0.01 inch. Yes, for doing close in work.
And you
at
can
25.
read that, can you?
Yeah, at 25 meters you can.
With your auto level.
Yes, 32x.
Do you have a micrometer on it?
Oh, God.
Is that I don't know what that is. Quick Google it. Is that somebody micrometer on auto level? Check it.
1/100th of an inch is 1/4 of a millimeter.
Yeah. And you can measure that with your auto level, can you, George?
You don't measure it. You look to see where you are on the graduations.
Yeah. And you can measure that.
If you're 2 graduations, if you're 3 graduations above horizontal, then you're 3/4 of a millimeter above. You don't measure it with the auto level. You count how many graduations you are, and knowing the distance between the graduations, you know how much in the vertical you are. You don't measure it directly with the auto level. You see where the auto level is sighting it, and you count the graduations, so you know physically how far off you are by knowing how many graduations and what the graduation scale is.
So you're
not measuring at all, are you, George? No.
Jesus, Bill.
You're measuring then, right, George?
Not taking a measurement there. Not at all.
Counting. That's what you're doing. You're counting.
Yeah, you look through the eyepiece and you see how many graduations off you are.
Yeah,
that's all.
That's like measuring, right? you would do the same with a ruler. You put the ruler up the side of something and you would count the numbers, wouldn't you? One,
Yeah, of
two,
course.
until you get to the bit that you want, and then you would call that a measurement, wouldn't you?
Okay, it's a measurement, fine.
Yeah. So can you do that with your auto level?
I just said I did.
You can measure to
Now,
the quarter
do
of
you,
a
do
millimeter.
you have problems with memory, Beth?
It sounds like
You
you
seem to
George.
have short-term memory issues.
Yeah.
George, can you pack it in with being childish again, please?
It's okay.
It's
okay. People get like this, you know. We know what it's like. Model afflicted, right, George?
battling Cogdis.
Yeah. It's one of the defense
At
mechanisms.
25 meters, you can read a quarter of a millimeter
Have you
using
got
a
a micrometer
32x
on that
auto level.
auto level, George?
Is what?
Have you got a micrometer on that auto level, George?
No, I do not. I don't need one.
So you can't measure to the quarter millimeter with it, can you?
Of course I can.
No, you can't, George.
A quarter of a millimeter at 25 meters is 1 arc second. That's fully within the capability of the auto level.
What? How big's your crosshair?
That's going to be enormous at 25 meters.
It's the same at any distance.
Yeah, so how
At the
big,
auto level,
how
you have
big
a
do you
scissor wedge
imagine your crosshair is,
on the
George?
auto level. You have a scissor wedge on the right-hand side. You can sight.
How
Even though the
big
crosshair might cover up your mark, you can center it up using the scissor wedge.
So have you got a scissor wedge on your auto level, George?
Yes, look at the
got a new
Topcon ATG2. It has a scissor wedge.
I'm just going off all of the pictures that you've given us in the past, George. I don't think I've ever seen any with the scissor wedge on it.
It's because I have centered it off into the center. The
okay,
scissor
now.
wedge is off to the side. You never see it in my images because I'm zoomed in.
He's such a lying. Yeah. Like, blatant lie. That is a blatant lie. George has never got a scissor wedge in any of the pictures he's ever shown us. And now he's trying to say it's off to the side. Well, the scissor wedge meets at the vertical. George is such a liar. How do you think they can get away with it?
Field of view is so narrow you cannot see the scissor wedge.
It's on the vertical.
No, it's on the horizontal.
Well know it is.
It's on the horizontal.
The scissor meets at the vertical.
No, it doesn't.
At the left-hand side.
The scissor wedge is on the horizontal.
Which meets at the fucking vertical, George. That's where the scissor is.
No, it isn't. No, it isn't.
Yeah, it is. It is.
Not on the Topcon G2.
It is.
Not on the Topcon G2. The scissor wedge. Oh, Jesus.
Yeah.
All right. You want to behave like a kid. I'll catch you later. Bye.
See you
Coming
later.
from you, George.
See you, George. Bye-bye. Have fun. Are you going to stick
Nope.
around? No, he's actually
No,
gone.
It's gone.
Oh, man. Right, there you go. I didn't think we'd get through that. This is not going to go away. Not going to go away at all. I'm just wondering who's going to be next up. Coming up very soon. I will be documenting all of this sort of stuff. And we'll see who else there is. Who's going to take up from George? Jesse Kozlowski's done a Jesse Kozlowski. The guy that probably never lived in Maine has done a Jesse Kozlowski. George has obviously done a Jesse Kozlowski. God rest his soul. It seems like Rumpus has done a Jesse Kozlowski as well. Unless me saying this can bring Rumpus back again. I'm not too sure. Might be able to. But Rumpus would be no good with surveying anyway, because Rumpus has never even looked at Bedford through his auto level, and he only had a 24 times scope one as well, a really shit one. These guys have been lying to people for quite a long time. People like George, people like Jesse Kozlowski, people like the guy that probably doesn't live in Maine, people like Blue Marble. I'm not too sure whether Blue Marble actually is lying or whether he's just been told by people like George and Jesse and the guy from Maine and whoever else he has supporting him. Probably. I mean, he might not be bright enough. I don't know. I do know that they do lie lots, and the people in this arena obviously lie lots. I don't like liars. I'm going to be cutting all of that stuff out. No more liars involved in any of this stuff. Okay, we're going to end up with Model Affliction. Tomorrow, join us tomorrow. We're going to be going over... I haven't even got a chance to go over it. We're going to be doing the philosophy course again. Now, I know a lot of people don't really like that, but that's where it's at. That's where you're going to learn all of the arguments. That's where you're going to sharpen your skills. And we will be, let's say, going on the attack pretty soon with arguments and discussions, real discussions, and people will learn a lot more about how all of this stuff works. We might have to go behind closed doors when we're doing it, though. Okay, thanks for watching. Join us tomorrow. It'll be a short half-hour session, and then we'll be going into the philosophy. So join us. There is some really good stuff coming up soon. Join us tomorrow. Thank you very much.
All right, here we go. Okay. Is it a hump or a drop? What do you say? You got to twist your words in every which way, because the motto will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line or does it curve? Some people unclamp it, but that is absurd. We all know that the model will always dictate what you do. Everybody knows that you are model afflicted blue. Model affliction. It's your addiction. That model affliction. It brings you so much pain. It's your ball and chain. Conflating curvature with elevation change has got your local distance just out of range. That old biggie is gonna dictate everything that you do. And everybody knows that you got the model affliction blue. It's your decision defending the model position. You just don't know the geometric proposition. That old ball, it'll always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction, it's your addiction. Model affliction. It brings you so much pain, it's your ball and chain.